Hello everyone and welcome to my channel Octopus Math by Sahiba. Question number 6. Abjit cycles from his home to the swimming pool. The travel graph is here. Okay, then this is cinema. This is the shop and this is the swimming pool and this is his home. Part A, write down where Abjit stops on his journey to the swimming pool. So, when he left his home and on his journey to the swimming pool, he passed through the cinema. This is where the cinema is, and he did not take a stop over this at the cinema. This is not a straight line from his home to the shop. It means that when he reached at the cinema, he kind of changed his speed, right? He kept going, but at a different speed until he reached the shop. And then at the shop, he waited for a while, which is about 5 minutes here, right? So now the question the answer to this question is write down where Abjit stops on his journey. So he stopped at the shop basically. He did not stop at cinema, but he just changed his speed. Part B. Abjit is cycling fastest between the shop, and the swimming pool. Explain how you know this from looking at the graph. Okay, now we can see this. It's because of the gradient. Gradient actually tells you how steep our line is. So gradient, you can say that gradient because it's steeper, because the line is steeper. Uh, okay, so yeah, shop and steepest. Okay. Part C. Abjit cycles at 20 kilometers per hour from his home to cinema. This journey takes 12 minutes. So the speed is 20 kilometers per hour and the time is 12 minutes. Right. We need to show that the distance is 4 kilometers. Now, this is the answer that's already given in the question. So, we cannot use this answer, but we have to reach to this answer. So, remember when we are talking about the formula for speed, it is distance upon time, but we need to make sure that distance and time must be with the unit that the speed has. Like, for example, speed is kilometers per hour. That means the distance should be in kilometers and the time should be in hours. Right, so speed is 20 kilometer per hour. If I'm using the same 20 kilometer per hour, that means the distance I will get will be in kilometers if my time is in hours. So 12 minutes basically is 12 divided by 60 hours, right? So this will go there to multiply. So S is equal to 20 times 12 over 60. So this is 3 and then this is 4. So my distance is 4 kilometer shown. Part 2, complete the scale on the vertical axis of the grid by showing at least two other values. All right. So home to cinema is 4 kilometers. This is home and this is cinema. From here to here, it's 4 kilometer. Let me see how many boxes does it have. 1, 2, 3, 4, 5, 6, 7, 8. So that means 8 kilometers, 8 boxes represent 4 kilometers, which means the next thing, if this is 4, then the next thing would be 8, and that too after 8 boxes. 1, 2, 3, 4, 5, 6, 7, 8. So swimming pool is 8 kilometers away from his home. Right, so 2 points are enough. They're asking for 2 points. Part D, calculate the speed in kilometer per hour that Abjit cycles from cinema to the shop. Cinema to the shop. So basically we need to calculate this speed over here. So first let's see how much distance has been covered. So for on the y-axis where we have distance in kilometers, we know that 8 boxes represent 4 kilometer, right? That means one box is a half kilometer, right? So here this point is going to give me 7. This is 7. So when we are talking about this line, this particular line, we need 2 points on the line to calculate the gradient. So let's do it by rise over run. So from this starting point, there is this is 4. So from 4 to 7, it's 3 units back up, and then he is traveling a horizontal distance of again positive. So from here to this time. So one block is 2 minutes, right? Because there are 5 boxes and 10 minutes. So one box is 2 units. So 2, 4, 6, 8, 10, 12, 14, and one half box, which is 15, right? So basically, it's 15 minutes. So this is in kilometers and this is in minutes, right? We have to write our speed in kilometer per hour. So what we do is we don't need this 15 minutes. We need the time in uh, hours, right? So 3 kilometers divided by 15 out of 60. This is in hours. So this when you solve this, you will get the speed in kilometer per hour. So 3 divided by 15 over 60 gives me 3 times 60 over 15. 3 fives are 15 and 5 twelves are 60. So it's 12 kilometer per hour. Right. Moving on, part E. When Abjit arrives at the swimming pool, it's closed without stopping. At the swimming pool, he decides. Um, at the swimming pool, he cycles home at a constant speed. It took them 24 minutes. All right. He did not wait at the swimming pool, and he took 24 minutes to cycle home. So, which means he started from here, and so he takes 24 minutes. So 24 minutes, because we know that one box is 2 units, 2 minutes. So 24 minutes is actually going to be 12 boxes. So starting from here, this is my starting point, and then I have to go for 12 boxes. So these are 3, and then 5, 8, 9, 10, 11, 12. So this is the point where, I mean, this is the time when he's going to reach. So I'm just going to try to make a straight line. This is roughly the line, my graph. Calculate the average speed in kilometer per hour for the whole journey. So the formula for average speed is total distance upon total time taken. So total distance is 8 and 8, 16, because going 8 kilometers and then coming back 8 kilometers. So it's 16 kilometers. And then from starting 10 to ending the journey at one box before 11, that means 2 minutes. So it's basically 58 minutes, right? So distance is 16 kilometer and the time is 58 minutes. Remember, we need the speed in kilometer per hour, so we don't want this 58 to be in minutes. We want this to be in hours. So what we do here is divided by 60, so that my time will be in hours. So 16 divided by 58 over 60 is same as 16 multiplied by 60 over 58. Let me quickly use a calculator. 16 multiplied by 60 divided by 58 gives me 16.55. So 16.55, right? Part G. Abhijit's bicycle wheel has a radius of 29 centimeters. Calculate the circumference of the wheel. All right, so circumference is 2 pi r and the radius has been given 29, and we need to round it off to one decimal place. So it has to be 182.21. So one decimal place is 182.2. Yeah, okay. Part 2, calculate the number of complete turns the wheel makes when traveling 500 meters. All right. So we know that this is a rate question. At one complete turn, I'm writing short form. One complete turn is basically one circumference, which is, we know that, 82.2. And this is in centimeters, right? And this is in 500 meters. It basically asks you that if it takes 182.2 centimeters for one complete turn, how many complete turns, which means we don't know the number of complete turns, will it make in 500 meters? So 500 meters is basically 50,000 centimeters, right? And then simply cross multiplying, 1 times 50,000 is 50,000, is equal to x times 182.2. So basically it's multiplying, it will divide on the, so 50,000 divided by 182.2 is basically 274.4. But because we're interested in the number of complete turns, we always need to run it off backwards. That's 274 complete turns, and then 275th turn is yet to be completed. Thank you for watching. Share my videos with your friends and family to spread the knowledge. Also, keep watching for more videos.